Negative angles. Negative angles are obtained by rotating clockwise from the positive side of the x-axis. So this is our unit circle, and this is the positive side of our x-axis. And if we rotate clockwise, we end up getting a negative angle. We're going to let P be the point corresponding to an angle of minus A. So here we have angle A, here we have angle minus A, and this is the point P. Then P is going to be cos of minus A, sine of minus A. So P is cos of minus A, sine of minus A being the angle. Let Q be the reflection of P in the x-axis. So Q is the reflection of P in the x-axis. So we can see that the distance from point P to the x-axis is the exact same as the distance from point Q to the x-axis. One is a reflection of the other in the x-axis. And these angles are equal. So for example, if this was 60 degrees, this is 60 degrees. Then Q is cos of A, sine of A. So point Q on the unit circle is cos of A, sine of A. P and Q have the same x coordinates and y coordinates, which are equal in size but opposite in sign. Thus, cos of minus A is equal to cos of A. Sine of minus A is equal to minus sine of A. And tan of minus A is equal to sine of minus A over cos of minus A. And sine of minus A is minus sine of A. Cos of minus A is cos of A. And a minus divided by plus is a minus. And sine of A divided by cos of A is tan of A. So let's have a look at these a bit more closely again. We know that cos matches up with the x-axis. So for example, with the point Q, the cos is the x and the sine is the y. So with the point Q and the point P, we can see that the x values would be the same. So this is our x-axis. So the point on the x-axis is the exact same for P and Q, which is why cos of minus A is cos of A. Sine matches up with y. So we know that this is x and this is y, so sine matches up with y. So this is our y-axis. And we can see that the value would be the exact same. So if we were to move our point Q over to the y-axis, let's say for example this was 0.8. If we were to take point P and move it over to the y-axis, this would be minus 0.8. So the value would be the same, but one would be positive and one would be negative. So sine of minus A is really minus sine of A. So a summary of our negative angle results: cos of minus A is equal to cos of A, sine of minus A is equal to minus sine of A, and tan of minus A is equal to minus tan of A. So we can see these on page 13 of the formula book. You do not need to learn them off by heart. Express sine of minus 120 degrees as a surd. We could of course add 360 degrees to the angle, but we will use the negative angle results here. So sine of minus 120 degrees is really minus sine of positive 120 degrees. 120 degrees is in the second quadrant, and sine is positive in the second quadrant, but then becomes negative. So having a look at our unit circle and following cast, we see this is the second quadrant. So remember, first quadrant, second quadrant, third quadrant, fourth quadrant. So 120 degrees lies in the second quadrant, where sine is positive. So in the second quadrant, only sine is positive, and we actually do have sine. So 120 degrees in the second quadrant, sine is positive in the second quadrant, but then it becomes negative because we're following our negative angle results, which tells us that sine of minus a is equal to minus sine of a. So sine is positive in the second quadrant, but because we have a minus, we have to then apply the minus, but it's only one minus. So for example, if it had been negative, we would be applying two minuses, and that would have become a positive, but in this case it just has the one minus. Sine of 120 degrees is really sine of 60 degrees, because again, 120 degrees is in the second quadrant. So we have first quadrant, second quadrant, third quadrant, fourth quadrant. We have 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So obviously 120 lies in between 90 and 180 degrees. And in the second quadrant, to figure out the reference angle, it's 180 degrees minus the angle itself. So 180 degrees minus 120 degrees leaves us with 60 degrees. So remember, it's minus sine of 60 degrees. Sine of 60 degrees is root 3 over 2. So minus sine of 60 degrees is minus root 3 over 2. So sine of minus 120 degrees is minus root 3 over 2. Now let's say we wanted to work it out the other way. We could have added on 360 degrees. So minus 120 degrees plus 360 degrees equals 240 degrees. Now 240 degrees lies in the third quadrant. So we have 0, 90, 180, 270. So 240 degrees lies in the third quadrant. And in the third quadrant, only tan is positive. So we know that sine will be negative first of all. And in order to work out the reference angle in the third quadrant, it's going to be the angle that we have minus 180 degrees. And 240 degrees minus 180 degrees leaves us with 60 degrees. So we still would have ended up with the same surd, because sine of 60 degrees is root 3 over 2. And remember, we are now in the third quadrant, where tan is the only positive angle. So minus sine of 60 degrees will still give us minus root 3 over 2. So whichever way you want to use it will work out. But obviously, for this example, I wanted to show our negative angle results being used. So summary of our negative angle results: cos of minus a is equal to cos of a, sine of minus a is equal to minus sine of a, tan of minus a is equal to minus tan of a. So again, you don't need to learn them off, but you do need to know how to use them.